Physics 2 Lab 1 Report by Caroline Miley. So for some intro and background to this lab, we had to create charged tapes called U-tapes, and both of them would end up having the same charge, therefore repelling each other. But we had to float one of the tapes on top of the other and figure out what excess charge was necessary in order for this to happen. So in my findings, I found out that both tapes were negative, and that the excess charge needed was negative 4.85772 times 10 to the negative 7. And in doing these calculations, some assumptions that we had to make was that each tape is just one charge, so treat each tape as a point particle, and that atoms are evenly spaced. Each tape has approximately the same charge spread uniformly throughout the length of the tape as well to do these calculations. Some other key concepts that we must keep in mind is one that comes from Physics 1. So the floating tape is actually motionless, therefore air resistance has no effect at all, so we don't even need to consider that. And F net ends up equaling 0 because due to the momentum principle, which I have here, delta P equals F net delta T, since the tape isn't moving, so delta P equals 0, therefore F net is 0. Then we break down F net into its components. So we break it down into the gravitational force and the electrical force, which the yellow arrow in the graph represents electric force, green arrow is gravitational force. So they need to balance each other out to equal 0. So electric force ends up equaling mg, and F grav is negative mg. The tape should also be handled as little as possible in this experiment, just because our hands have particles in them also, even though we don't think of them as charged, and it ends up neutralizing the tape. So to find the charge, we also use the equation for the electric force, which is electric force equals Q times electric field. Now we don't actually have the electric field because we would need the charge to do this. So then we have to break down electric field even further into its smaller components, which is K times Q divided by magnitude R squared. Then we do some algebra and solve for Q. So the mass of the tape, which I measured, was 0.000199 kilograms, separation distance 0.033 meters, and the number of atoms in the tape ended up being 1.99 times 10 to the 9. And the ratio of electrons to atoms is this number right here, which makes sense because there should be an excess amount of electrons per each atom. And the tapes ended up repelling each other, which I could tell that it was a negative charge because I compared it with a plastic pin that was rubbed on my hair, and we know that that gains a negative charge. Therefore, since the tape repelled the pin, it had a negative charge as well. If it had been positive, it would have been attracted. Now time for the code. So this is my code. I define my constants here. I have Coulomb's constant, charge of electron, mass of tape, particle positions. Here, particle 1 is actually my top tape and particle 2 is my bottom tape. And then I did the calculation for gravitational force, and I have the position vector. And then I also have the equation where I have solved for Q. So this is that equation right here in line 22. And then I defined arrows to show this in the graph. My gravitational force makes sense because it's acting downwards, pulling the particle towards the ground. And then the electric force makes sense because it should equal out the gravitational force and end up being 0. So that's why the particle ends up being stationary. The charge needed to float the tape is a negative number, which is negative 4.8, rounded up, negative 4.86. And it makes sense that it's negative because the charges are both negative, so therefore there needs to be an excess negative charge in order for the tape to float. And then the excess electrons is a positive number, which makes sense because that's the amount of electrons that are needed, and they obviously have a negative charge. now back to the PowerPoint. So in conclusion, from all my findings and considerations and assumptions that I made in this presentation, if electrons had a positive charge and protons had a negative charge, not much would really change. Pretty much the interactions would remain the same. It's just that the charges would be a different sign. So if the two tapes had electrons that had a positive charge, they'd still repel each other, but they would end up, the calculations would have different signs on them. So the excess charge would end up being positive, but it would still be repelling. And that's it for my presentation. Thank you.